Question 17, we have an exponential function. The function f is defined by the given equation where k is a constant. The value of f of x increases by p% for every increase of x by 1 here. For which of the following functions where k is a constant does the value of x increases by p%, again the same p%, but for every increase of x by 1/4? So here we have to remember, because the exponential function has many keywords you need to consider. So remember this: y is equal to a times b to the power of x over c. For the value of y, we are talking about the total. For a, we are talking about the initial or the starting. B is the rate or increase or decrease in the value, which contains a percentage. And then the x is the time. But this c is coming after the word every. Every something, you are talking about c. So here it says every increase of x by 1/4, it should be written like this: some y is equal to something times something power x over 1/4. Because we have to write the word every below the x, as you can see, instead of this value of c. So x over 1/4, this 4, because it's denominator of a denominator, it should be going up to the numerator. So y is equal to a times b to the power of 4x. So here 4 is divided twice, which makes it a numerator like this: 3 over 1/2. It makes it 6, 3 times 2. So that's what happens here. So now we have an exponent of 4 times x, which is given only in letter B. So of course 1.83 is repeated in all the options. K is the initial value, but the difference of the options is here: 4 multiplied by x, as you can see here, which is given as letter B. Question 18. A line intersects two parallel lines forming 4 acute angles and 4 obtuse angles. The measure of one of the acute angles is 9x minus 490. Let's draw this. We have two lines parallel, and then this line is then a transversal. And we have angle A here. It's acute angle, and of course this will be also A. If this is B, this will be B, and the same happens here. One of the acute angles, which is A, is equal to 9x minus 490. And the sum, so what is B? B is the obtuse one. So let's write B as 180 minus A. So of course, when you have A and B as linear pair, one of them is equal to 180 minus the other. They are called supplementary angles. So let's consider this is A and this is B. And now we have the equation. The sum of the measure of one of the acute angles, which is A, and 3 of the obtuse angles, which makes 3b. The sum of A and 3b is equal to what? Negative 18x plus w. This information can be written on Desmos to get the value of w. Let's make them together. We can write a list of values. And in the middle, we write this sign, tilde, and then we write in the left A. And then the value of A is 9x, but we just write x1 minus 490. And then we write B, and B is equal to what? 180 minus A. In the left, we need to get to write this equation here, comma, A plus 3B. And in the right, we're at the value of A plus 3B, which is negative 18x1. Make sure to write x1 plus w. And then, as you can see, w is given here, 1,520. 1,520 is the value of w. Question number 19. The exponential function f is defined by f of x is equal to a, b to the x power, where a and b are positive constants. If f of n equals to f of n minus 1 is equal to f of n plus 82 over 100, f of n minus 1. N is a constant. What is the value of b? We can write this on Desmos, but we can make it simple by considering, instead of f of n minus 1, we can say a, b to the n minus 1. because f of x is ab to the n, to the x. So f of n minus 1, ab to the x minus 1 equals f of n, which is ab to the nth power plus 82 over 100. And instead of f of n minus 1, we write ab to the n minus 1 power. So we can write this on Desmos, and then we can provide the Desmos with some values of a and n as, let's say, positive values. And we see the value of b. So we can write a list here and this sign between them. And in the left side, we write ab to the power of n minus 1. Make sure to write them inside the parentheses, n minus 1. And then this will be ab to the nth power, right? N here, and in the exponent. And then plus 82 over 100, 82 over 100 f of n minus 1, which is ab to the power of n minus 1 inside the parentheses like this, n minus 1. And we give, as we said, some values for a and n, a comma n, and then we give numbers like any number greater than 1, let's say 3 comma 3, for example. And then b is equal to 0.18, which is our answer. Then question number 20, the area of a rectangular region is increasing at a rate of 180 square centimeters per hour. What is this rate in square meters per minute? So we can write them in a rate like this. The area of the rectangular region is increasing at a rate of what? 180 square centimeters per hour. 180 square centimeters, which makes centimeters squared, per hour means 1 hour. And then we need to change this to be in square meters per minute. So square meter, the 1 meter is equal to 100 centimeters. So 1 square meter is equal to 100 squared times square centimeter. So if you want to square this, square them all. The 1 squared is equal to 1 already, and the meter should be squared, 100 also squared, and centimeter to be squared. So now we can use this formula instead of this one, because we are talking about the squares. So centimeter squared. How can we change the centimeter squared to be meter squared? We are moving from right to left, or from the smaller unit to the bigger unit. So we divide. We have to divide by this number, 100 squared. And because we need to change from hour to minute, so we multiply, because the hour contains 60 minutes, multiply by 60 to get the number of minutes. So we just write this on the calculator. We can write them here. We can make a fraction bar and write 180. We make over and go up and write divided by 100 squared. And in the denominator, we can write 1 times 60. And we get this answer. But of course, we cannot write this because we have only 5 spaces to write the answer. So we can write 0 at right point, and instead of this 0 at the left, write point 0, 0, 0, 3. Now we have 5 spaces, 1, 2, 3, 4, 5, 5 places to write the answer. Question 21, we have this equation. It's a quadratic equation. In the given equation, b is an integer. The equation has no real solutions. What is the least possible value of b? We can consider writing the discriminant, which is b squared minus 4ac. This must be, if we have no real solution, it must be smaller than 0. So we can substitute. And b is the same as b squared minus 4a. And a is -1. And c is negative 169. And this is equal, less than 0. Now b squared, if you calculate all of this, you can do them on the calculator. Negative times negative times negative is positive. So just write 4 times 169, which is equal to 676. So minus 676 is less than 0. Move this number to the other side. B squared is less than 676. And here, this is it's called a quadratic inequality. If you want to solve this, you get the square root of this one and this one, but make sure to write the positive and the negative, which makes p in between these two numbers. The negative square root of this number and the positive of the same square root number. So we can just write the square root of the answer, which gives us 26, but you need to write negative 26 here and positive 26 here. And that's how to deal with a quadratic inequality. So any number between negative 26 and positive 26. Maybe this number is 24, 25, 0, negative 25. The least number, what the least number is negative 25. Why not negative 25.5, for example? Because it's an integer. We cannot take any decimal. How can we do that on Desmos to make it maybe simple? We just graph this. You can write negative x squared, negative x to the power of 2, plus bx, and then minus 169. Just do that. No need to write equals 0, and that's the equation of the graph. Let's make it. Let's zoom in to see the graph. Of course, the graph is away because of these numbers. Just click equal and click enter, and then you get this graph here. How can we make sure that this has no real solution? No real solution means that this curve or this graph cannot touch the x-axis. Let's make it clear here. And then how can we make the b move to reach the value, the x-axis? So let's make the slider a little bit wider. Let's start from negative 50 to positive 50 to see everything. So once you move the x-axis is here. If you move this number b, it will come here and touch the x-axis at the point 26. But we do not need it to touch the x-axis because we have no real solution. So we just move a little bit down, and instead of 26, you make it 25. Look at this, 25 is okay. But this is not the least number because we still have a number smaller than 25. If you move like this, 24 is okay, 23, and so on, until we reach this. Look, it comes again in the other side and moves again up to come closer to the x-axis. We do not need to touch the x-axis. So negative 26 is not a correct answer. So we just move one step to the right and stop at 25, negative 25, which is the least number to get as a value of b. Question number 22, 1 over r is equal to 1 over p plus 1 over q plus 1 over s plus 1 over 13. A parallel electric circuit contains 4 resistors with resistances of p ohms, q ohms, s ohms, and 13 ohms. The given equation relates the resistance R in ohms of the circuit to the resistance of the 4 individual resistors it contains, which equation correctly expresses R in terms of P, Q, and S. We need to get R alone. So when you have the 1 over R, how can we get R from 1 over R? By making the inverse. I mean, for example, if you have 1 over X equals to 7 over 8, you can say that X is equal to 8 over 7 or 1 over 7 over 8. So we can do that here in the value to get the value of R. So if you want to get R here, we write R equals to 1 over all of that. 1 over P plus 1 over Q plus 1 over S plus 1 over 13. And of course, we cannot find this on the options, so we need to make some changes in the values here. So how can we do that? We can multiply up and down by the least common multiple. What is the least common multiple of these 4 values? It's the product of them. Least common multiple is equal to P times Q times S, this is S, times 13. So we can write 13 P Q S. Let's write them up and down here. 13 P Q S, 13 P Q S. And we multiply this by 1 to get the same number. So R is equal to 13 P Q S over. This should be distributed to all of them. So let's start by multiplying it by the left one, by the last one here, or the first one. When you multiply this number by 1 over P, the P cancels P. So we are left with 13 QS. Of course, this is multiplied by 1 to get the same number. Plus, when multiplying this by Q, the Q is cancelled, so we have 13 PS plus multiplying this by s cancels the value of s, and then we have 13pq. And the last one is when you multiply this by 13, the 13 is cancelled, and we have only pqs, which gives us the answer letter B. I hope you understand the ideas inside this exam, which are very important to consider, to practice on, and see you in the next videos.